Hello everybody, welcome to this webinar brought to you by BERHAD Malaysia. Okay, today we are going to talk about this topic, rise of 5G from infrastructure to consumer devices. All right, like the title suggests, today we are going to dive deeper into this 5G infrastructure and see which companies can benefit from this the rise of 5G. Now, before we move on, this one do one important slide, which is disclaimer. As usual, whatever we share on this webinar is only for educational purpose. In no way that I give any recommendation to buy or sell any companies. So in the event that you want to buy or sell any companies, you do it at your own risk. Is that okay? All right. So now allow me to introduce the speaker. All right, he is back by popular demand. Okay, we have David Paul here in the house with us tonight. So David is an engineer by training. He began his career as an engineer in the telecommunications industry for 10 years before turning to his passion in value investing. He served as a director in a local equities education and research firm for 3 years, managing research factors, efforts and delivering advanced value investing and portfolio management education series. Thereafter, he started to pursue his own aspirations, establishing the Spiral Thinker Group, a collaborative alliance to promote intelligent value investing and develop algorithm-based adaptive portfolio strategy for sustainable long-term wealth creation. So David is now a full-time investor and dedicates his time and resources to nurture the youth in financial literacy. He's often invited to speak in broker seminars, webinars, as well as Bursa's endorsed events, and his professional comments and opinions on value investing are featured in business publications like Focus Malaysia. So David also provides consultancy services in value investing and advanced portfolio strategy for high net worth individuals. So this is David for you. So he is ready. Get started. Are you guys ready?
Okay, thanks a lot, Chun Xian. Let me show my screen.
All right.
Show my screen. Okay, can you confirm that you can see my screen?
I have. Yes.
All right.
We can see your screen.
Okay. Good evening, everyone. Nice to be back again. Thanks for joining us. First of all, I'd like to thank Chun Xian, Life Champ, as well as Busan Malaysia, for inviting us back again to talk about this very, very interesting topic about 5G. Yeah. Okay. Now, if you remember, I think last month I was here to talk about, to introduce about, the investment opportunities in technology in semiconductor supply chain. So this is do consider this as a part of the story. So this is on the second installment, just like a trilogy. Yeah. For tonight, we'll be focusing on 5G. Okay, from infrastructure to consumer. But before I continue, before I start, I would like to acknowledge that the materials presented in this webinar is not entirely by my own. It is actually a collaborative effort by my team, the Alpha Research Team in Spiral Thinker Group. Yeah. So by all means, let's start. So tonight, we break the topic of 5G from infrastructure to consumer to the following agenda. First, we talk about the evolution from 2G, from our very basic those big bulky phone 2G to 5G today. What are the major breakthrough behind the technology breakthrough behind this 5G? And most importantly, after that, we will talk about what are the use cases of 5G so that we can see what are the how applicable is this technology in today's world. Okay, then after that, we'll move on to the more technical part whereby we talk about a little bit about the infrastructure, which I personally coin them the invisible highway that makes 5G possible. And then last but not least, we are going to go a little bit deep dive, not a very deep dive, but a basic deep dive into the supply chain of 5G consumer devices, particularly connecting back to the investment opportunities in KLSA. All right, so without much further ado, let's continue. Just a quick recap from our previous webinar. I hope you remember this. The reason why I show this is actually to synthesize, to show that actually technology is always here to stay. It's just that the focus changes over time, different eras. When we started out, it was computer-centric. Then it moved on to mobility. And last but not least, is what we are going through today is all about data. Okay, and of course, I show this a hype cycle of the emerging technologies as well by Gartner and Deloitte. The key message that in the previous webinar was that, you know, for all these future technologies to happen, to be realized, right? 5G needs to be there because 5G is the enabler. If I put it very simply, 5G is the enabling technology for future emerging technologies, including IoT, in Industry Revolution 4.0, autonomous vehicle, AI, so on and so forth. Yep. Okay, so I hope that you guys still remember that. Now I'm going to dive straight away into the cellular technology evolution. Okay, now this is a very colorful slide that I got from the National. I have been using this slide for a couple of years now. First, let me explain to you what is the meaning of cellular technology. The word cellular implies, you know, different areas, like we call it the cell. Basically, this cell refers to the coverage area of a service. Okay, now why are we able to talk on the phone, to surf the internet from a mobile without having a without having a cable? Because it is enabled by wireless communication. And this wireless communication, every time we are online, every time we're on a call, we are being served by a structure called the base station. All right, you may see some of the towers around you. Some of the towers are very big, some are very small, some can be on a lamppost, so on and so forth. As you move from point A to point B, the data communication is being handed over from one cell to another, and that is why it's called cellular technology. So when we talk about cellular technology, it basically means the mobile communication, right? The wireless communication. Now, as you can see from the picture in front of you, when we started out, when the true mobility started to boom, to take off, we started out with 2G, right? Back in the 1990s. I don't know how many of you are born or haven't been born yet, but you know, that time the central theme is about voice, right? You carry a phone. The main reason is for you to talk, to communicate through voice. Now, then came and then there is a SMS. You know, I don't know whether you guys remember. It used to cost us 20 cents to send one SMS with 255 characters. Yeah. So as we move along from 2G to 2.5G, then to 3G. Now, 3G is a paradigm shift whereby the focus is not just on voice, but towards data as well. Okay, that's why we get MMS, you know, multimedia messaging services. That's why we get pictures, messages. But to surf YouTube or to stream in 3G is, you know, it's a complete havoc, right? It's a very torturous experience, if you know what I mean. Okay, now that is what gave rise to the need of a new technology that enables seamless streaming of data, of multimedia, and that's where 4G came about. Now, 4G to me as an engineer is actually like an intermediary technology. They are not there yet, but they are a good transition between mobility and true immersive experience of being able to surf seamlessly, download at super speed, and so on and so forth. And that is why you can see that between 2G, 3G, right, it takes about 10 years for the technology to mature, as well as paving the road path to the next technology. Now, 4G is a bit fast-tracked, so it's less than maybe 6-7 years before 5G takes off. Yeah. So the key thing here is from 2G to 5G is about voice-centric to data-centric, then to multimedia-centric. Now, the term multimedia maybe is a bit overused since many years ago, but true multimedia includes everything from voice, data, pictures, movies, and in the future, augmented reality, so on and so forth. Yeah, these are the true immersive experience that we have yet to experience. Okay, so what are the major differences? So we're going to focus a bit on 4G to 5G because they are more relevant. Okay, now I don't know if you remember 3G, very historical, prehistoric, I call it prehistoric data speed of 384 kilobits per second, right? I don't know how many of you remember this. Then of course, when 4G came about, they promised 100 megabits per second, but of course, these are theoretical download speed. Then 5G again promises much higher of 10 gigabits per second, but that does not mean that your 5G phone will be able to serve at 10 gigabits per second. It basically means that is the maximum capacity bandwidth that you are able to serve. So you got to remember that one service has to be split to many users, so you have to have a way to manage these resources. Yeah, but next question is that you have to think about is 5G only about speed? Is 5G only about getting light fast bandwidth? Right? Actually, it's not. 5G is so much more than speed, as you can see from here. This is a snapshot from Qorvo. So this is a comparison between the key differences between 4G and 5G, from peak data rates to traffic management to spectrum, and the most important thing there is actually about latency. Now, a lot of people do not understand what latency is. No worries. Later on in the next few slides, I will talk a little bit about what latency does. Yeah. Okay. So these are the major differences between 4G and 5G. So what are the major technological breakthrough that allow 5G to come about, to allow 5G to be realized? Okay. Why can't the maximum speed be achieved in 4G, right? So other than the technological or physical limits that we recall, okay, there are also advanced features like what is shown in front of you that actually differentiates between 5G to the previous preceding technologies. So mainly speaking, we are looking at five major technological breakthrough. We've got the millimeter waves, small cell, massive MIMO, beamforming, and full duplex. Don't worry, I know it may sound too technical, right? It may be a little bit overwhelming to you, but there is a good reason. I have a good reason why I want to introduce this technology to you first. Then at least as you understand the technology, then you know where to smell the money later. Yeah. But of course, for the purpose of this webinar, I'm not going to talk about all of these five. In fact, I'm just going to focus on three. The first three, which is the millimeter waves, the small cells, and the massive MIMO, because these three major technology breakthrough. If you can understand the concept behind these breakthroughs, you understand why 5G is so exciting. Okay, so without much further ado, let's start with the first one. Wow, David, I'm not an engineer, so why are you giving us this kind of formula? Don't worry, I'm gonna break this formula down to very simple terms for you guys. Okay, now first thing first. Remember, 5G is the first thing that 5G promises is very high data rates, very high download speed, very fast upload speeds, right? So how does this speed come about? It's all about capacity. Okay, now I'm sure a lot of you will understand how a typical manufacturing outfit runs. For example, if you produce coffee or you produce gloves, so basically you need many lines to produce more and more products, right? Now, in terms of communications, in terms of cellular technology, the concept is the same, but the way we measure capacity or we build capacity for communications is through the availability of spectrum, and then on top of how many cells you have. So this is the basic formula for how a capacity is being structured for communications. Yeah. So there are three components: the spectrum efficiency, and the number of cells. Okay. Don't worry if these names sound alien to you. I'm going to break it down to very simple terms so that you can remember all for life. Okay. Now, spectrum physically is the radio waves in the air. Is the medium, is a channel for the data to communicate without cable. So in an analogy, you can imagine spectrum as the highway. Okay, as the highway for you to, for data to ride on the highway. So on the highway, the data, if you can visualize the data like small packets, it's like a car. Many cars, big cars, small cars that transport different services, all right, on the highway. Okay, but first you need to have a spectrum. You need to have the highway. Okay, now then the spectral efficiency is the quality of the road on the highway. Okay, meaning is the roads made of stones? Is it made of this bitumen? Is it made of very smooth material, or is it crooked? Is it bumpy? This is like the spectral efficiency. How efficient is this spectrum able to carry the data through? All right, how fast it can go, and how many errors that it can tolerate, so on and so forth. And last but not least, the number of cells is like the number of lanes on the highway. Now, logically, the more lanes you have, the more traffic you can carry, right? Okay, so imagine this as a highway, you'll be able to understand. Okay, now it is very important, essential for you to understand this, because in order to understand what 5G is, you need to have at least this basic concept. Okay, now first we talk about the spectrum. Spectrum, as I mentioned, is the invisible radio waves on the air. Now, sometimes people complain, 4G, 5G is not good for my health because of the radiation. Ladies and gentlemen, I'm sorry to say that from my professional opinion as a former engineer, right? No matter where you are, you'll be exposed to radio frequency. You'll be exposed to radiation on the air because it is everywhere. Okay, so I'm sure when you wake up in the morning or you're driving a car, you tune the radio stations, right? Like 98.8 megahertz or 89.9 megahertz, so on and so forth. So these are the radio frequencies. Now, between 30 kilohertz, which is around here, to 3 gigahertz is what we call the radio frequency band. Okay, now this radio frequency is very wide. It can be used for many services. It can be used for AM radio. It can be used for FM radio, shortwave radio, your walkie-talkie. It can be used for TV and mobile transmission. Okay, our 2G, 3G, and 4G mainly resides in this channel called the UHF, called ultra high frequency channel. Okay, as if we expand it, right, you can see that anything between 300 megahertz to 3 gigahertz, there are a lot of different types of services, including TV and mobile. Okay, now here's the thing about spectrum. When it is just voice or very basic data, you don't need to have very high frequency, because the higher the frequency, you can carry more data. So remember that 5G promises a data speed of 10 gigabits per second, which is 100 times more than the 100 megabits per second that is promised by 4G, right? So you need to have higher frequency. That is why naturally, in order for 5G to really work, right, we need to look beyond the radio frequency band, which means beyond 3 gigahertz. All right, between 3 gigahertz to 30 gigahertz is what we call the microwave. All right, the micro is just a name, right? Don't worry about it. Then above 30 gigahertz is what we call millimeter wave. All right, now is this like a wavelength? The higher the frequency, the faster it will oscillate, and the faster it can oscillate, the more data it can carry. Simple as that. Okay, so 5G will be rolled out in different stages. It doesn't mean that 5G will only use the service will carry out in microwave or millimeter wave. In fact, the first phase of 5G will be carried out still on this ultra high frequency. So probably in a range of between more than 2 gigahertz, all right, but below 3 gigahertz. Then eventually, as the technology matures, as the technology advances, then we will have more and more services above the, beyond the radio frequency, which is the microwave and the millimeter wave. And that is where we can really see the advantage, the superiority of 5G over the preceding technologies. Okay, so I hope you're still with me. All right. Now, there's one problem, as I mentioned before, having high frequency is good because you can pack more data to send over the air, right? But the higher the frequency, there is a physical situation, a physical characteristic, whereby the signal that you send will diminish very fast if you send it over very high frequency. Now imagine it's like, when you throw a stone on the pond, and then when the storm hit the water, you see these ripples, right? Okay, now when you have very small ripples, which means high frequency, the the ripples cannot travel very far compared to ripples that is very far apart. In another example, when you talk to your friend, which is social distancing now these days, right? 3 meters away, right? You can hear very clearly. But if your friends, if this person, your friend, stands very much further apart from you, all right, he may not be able to hear you properly, and this is what we call the path loss phenomenon. All right. Now, the higher the frequency, meaning it is easier for the signal to lose its strength over some distance. All right. Now, that is why many years ago, I don't know how many of you are DG users. If you are, thank you very much for supporting my business. I'm a DG shareholder. Many years ago, DG do not have access to the lower frequency like 900 megahertz. Only Cellcom, Maxis, so on and so forth, they have access to that. That is why many years ago, I have a lot of friends complaining to me, hey, DG service sucks. Why? Because when you go underground or you go to the parking lot or you go very high up on your building, right, you get no signal at all, right? And that is the reason, the path loss, because DG only operates at 1.8 gigahertz and above. They do not have any spectrum in below 1 gigahertz. But a few years back, they did a refarming of the whole spectrum, meaning they reshuffle the whole assignment of the spectrum, and to be more fair across all the major telco in Malaysia, right? So that is why they started, DG started to improve their services, okay? So this is one of the reasons why higher frequency we have this problem. So having this problem, how do we solve it, right? The engineer will think, oh yeah, okay. So he will say that if your signal cannot travel too far, then you build more base stations in between. Sounds logical, right? You build more transmitters in between. That is why we call you increase the number of cells so that more cells can service more people in a shorter distance in order to compensate the path loss of the high frequency signal. Okay, so in 5G, we have this phenomenon or this feature called the network densification, meaning we try to make the network as dense as possible. We try to plant as many base stations as much as possible. Now, as I during my introduction just now, I talk about the very big towers, right? It can be 4 legs or 3 legs. I'm sure you saw the red white kind of towers, right? Now, future towers may not be so big. It can be as small. You won't even see it if you don't really observe around you. It can be on the lamppost. It can be on a traffic light. It can be on a roof. All right, very small. And of course, there'll be different hierarchies. Like, for example, the big towers is what we call the macro cells. It can serve as far as 3 to 30 kilometers. Then we got the smaller micro cells that can serve as far as 2 kilometers. Then we have this much smaller one. It's like your personal hotspot. All right, whereby it can serve between 100 meters to 200 meters to 100 meters. All right, called picocell and femtocell cells. All right, now this is how we are able to circumvent the problem of path loss in very high frequency. And with more base stations as well, more cells as well, we are able to deliver more services to the end user. Okay. All right, so this is about the network densification. Just to recap, to increase capacity, we need higher spectrum, we need higher frequency, and we need more number of cells. Okay, so now to talk about the third element, which is the spectral efficiency. Remember, it is like the quality of the road. Yeah, so just understand that from 2G to 3G to 4G, right? The efficiency of the spectrum, how the spectrum is being utilized, to generate capacity, right, is improving. It's like your production line, like I think Top Glove many years ago, their older machines get to produce, I don't know, 20,000 pieces of glass per hour, right? Nowadays, they can produce more than 40,000 glass per hour. So it is the same concept right here. Is the spectral efficiency, how it is being used. Okay, now of course this chart shows all the way until 4G or what we call LTE only. Now 5G is at least 3 times more efficient than the LTE with MIMO. Okay, 5G is 3 times much more efficient, which means that they can actually carry more data. They can carry more capacity, right, with this technology. And how is this possible? Simple. Is by using MIMO. MIMO stands for multiple input, multiple output. Okay, now don't worry about the name. The concept is very simple. Now, the picture in front of you now shows the current 4G, a typical coverage of a 4G base station. Now, this is true also for 3G as well as 2G. Now, basically, imagine now this is your tower, right? So the coverage is like this, it's expanding. All right. So as long as you are in this coverage, right, matter whether you are nearer or further or in the middle, you'll be served by this one tower here. Okay, and normally one tower has 3 directions, meaning they have 3 antennas to serve different directions. All right. Now there's one problem. The user who is nearer to the tower, remember path loss? They will be able to get better signal compared to another user who is much further away. All right, because the power is evenly distributed across the area. Okay, now with 5G, where we introduced the technology called MIMO, multiple input, multiple output, or what we call the active phase array antenna. You just look at the picture, right? So instead of a normal distribution like this, all right, where the coverage just sweeps across the area, right? Now the technology, the antenna can focus, pinpoint on that particular user. For example, in this area, serving area, there's a lot of users around here. So what the base station and the antenna is smart enough to focus the energy, the power to that particular area, so that it increases the power density and efficiency for that angle. Then at least the communication would be much more efficient. If there's not a lot of users on the another angle, then they will conserve the energy and focus there. And the best thing about this is that the technology is able to follow the users around. Meaning, if you are driving, right, the array will be able to follow you. Okay. Now, this is one of the technology that will improve the efficiency of the spectrum. Okay. So I hope you understand. I hope I made it easier for you. So this is both true for the downlink, meaning from the base station to the user, as well as from the user back to the base station. It is a two-way traffic. Okay, so that's about the 3 elements, the major technology breakthrough that enables 5G to be able to deliver such amazing benefits for us all. Okay, now there is still one problem though. There's still one very, very big problem, which is latency. Now, what is the meaning of latency? If you are in the IT line, you understand what I mean. Now, latency is basically the time it takes for you to transmit a data to another point and for the data to come back. It's a round trip, they call it a round trip time. All right. For a typical, so basically, I think if you're on time or you're on Unify, your typical latency is about, I don't know, 10 milliseconds or 20 milliseconds, meaning for you to send the data out into the internet and for it to reply back to you, it takes about 10 to 20 milliseconds. Now, of course, to us human, we can't really experience what is the difference between 10 or 20 milliseconds, but to a computer, they can precisely pinpoint what are the difference. Now, in 5G, they want to reduce this latency all the way down to 1 millisecond and below. This is one of the most important or most exciting features about 5G other than the data speed. Now, why is this important? Very low latency, like 1 millisecond, is required for your smart manufacturing. Now, imagine if you're producing 40,000 pieces of glass per hour, right? And there is a delay in your network. Can you imagine what is going to happen to your production, right? It's going to be a mess, right? So latency is very important for automated production, like your smart factory, your gaming experience. Nowadays, we play games, we don't install anymore, we actually play everything on the cloud. Is very important for virtual reality or augmented reality services, and most importantly, for self-driving cars. We talk a lot about autonomous driving, right? Meaning you just sit there and then the car will drive on its own. Now, these cars, these vehicles or these machines, they need to communicate with the network because the brain is not in the car. The car has its own small brains called the modules, but a lot of the processing will be processed either on the edge or on the cloud, on the data centers, right? So the communication has to be very fast. Now, can you imagine if the car, if you're sitting on a self-driving car and the car is going at 100 kilometers per hour, right? And then suddenly a child suddenly appear in front of you, and the car, if the latency is 10 milliseconds, right, I think chances are the car will hit the person in front already. So this latency is very important for advanced use case like this. Okay, so how is 5G able to reduce the latency so much until it's down to 1 millisecond? It's basically through two things. One is called the edge computing, and secondly is through the use of fiber optics. Okay, now very simply said, edge computing is like the intermediary between your gadgets or your things or your vehicle to the cloud, to the data centers, the core network. Okay, so between this, we can actually put a lot of computers called the edge computers to actually speed up the processing. The essential feedbacks we can process at the edge layer, and then straight away feedback to your machines so that they can react. Then perhaps the post-processing data can be fed back, can be communicated to the cloud. Now, so that is about edge networking, and this requires a lot of machines, a lot of switching equipment, a lot of fiber optics as well. Fiber optics is the other one. Now, maybe I can show you in the next few slides, I will show you what are the conventional way how towers communicate with each other, and then how in the 5G world, how the towers will be able to reduce the communication between themselves by using fiber optics. Okay, so let's just keep this in mind for now. I'll explain a little bit more later. All right, now next we move on to the promising use cases of 5G. Why is 5G so different from 4G or the predecessors, right? Basically, in the technology world, they have three naming conventions. One we call the EMBB, MMTC, and URLLC. EMBB stands for Enhanced Mobile Broadband. Wow, such a nice name, right? It basically means higher data speed. Higher data speed will improve our experience using the internet. It will allow the ISPs, the network providers, to give more services like virtual reality, augmented reality, real-time gaming, console, things like that. All right, so that's about enhancing your broadband experience from 100 megabits per second to a theoretical maximum speed of 10 gigabits per second. Next is what we call the massive machine type communication, MMTC. In other words, this is all the IoT, Internet of Things, where machine talk to machines, right? It's used in transportation, it's used in environmental monitoring, it's used in your metering. Next time you don't need a officer from Tenaga to come to your place to read your meter. In fact, everything can be done through the 5G internet. Okay, and last but not least is what we call the URLLC, the ultra reliable low latency communications, where latent response time is of absolute critical importance, like your smart manufacturing, as I mentioned, autonomous driving, so on and so forth. Okay, now the reason why I explain this is to show you that 5G will not happen like that. It has to be rolled in phases. Okay, so the first phase will be the easy one, like enhanced mobile. Yes, why? Because as you can see from here, enhanced mobile broadband, the focus is on speed. That's why we talk about pumping much more capacity, higher and higher speed, from 100 megabits per second to 1 gigabit per second, then to 10 gigabits per second. All right, and latency is tolerable, 20 milliseconds or below, which is very much what we are experiencing right now. Okay, now as you can see, along the years where the technology improves and matures, right, this is where we can introduce more and more advanced use cases, like your smart industry, your fleet and inventory tracking. So these are about tracking. all right, whereby you need a very high reliability, meaning the internet cannot be down anytime, and also manageable latency less than 5 milliseconds. Then only in the future, in many years down the road, where we talk about, where we need to have very high speed, highly reliable, low latency services. Now, can you imagine in the future, a surgeon do not need to be physically there, all right, to operate on a patient. In fact, these days they have the machine already. It's called Da Vinci. If you go to Glen Eagles Hospital, right, they got this huge machine. But the problem is, the surgeon needs to be there physically in order to use the machine. Now, imagine in the future, say 2023 or 2025, right? The surgeon can be an expert from US or from Korea or from China, and he can operate on a patient in Malaysia by using the same machine, but control over the internet. Now imagine if we do not have very low latency and the surgeon start to cut the patient, cut halfway, it releases, but because of delay, the machine still keep on cutting, it's going to be a disaster, right? So you can imagine the importance of low latency for all these advanced services like medical industry, so on and so forth. Okay, all right. So the important key point here is 5G services, the technology will be rolled out in phases. Okay, then all right, this is just another illustration to show you that with different services, the demand for latency is going to be more and more stringent. From your standard Google search, like survey internet, we can tolerate 1 millisecond delay because, sorry, 1 second delay, because to us, we don't really feel it. All right. But as the more and more advanced services are being rolled out by 5G, right, facial recognition, intelligent transport systems, you can see that the demand for the latency is becoming more and more stringent, up to smart grids, tactile internet, motion control, fully automated factory, smart manufacturing, so on and so forth. It requires less than 1 millisecond. All right. Now, I don't know if you realize, actually, this is the road towards the true industry revolution 4.0. That is why I mentioned that 5G won't happen just like that. It has to be brought in phases. Okay, so these are some of the very advanced use cases of 5G. So next, I'm going to move on to the invisible highway. All right. Now, one of the reasons, or one of the features why 5G can be delivered with such high speed, all right, especially latency, is because of fiber. Okay, now this is a report on the right hand side. This chart is from Bank of America. It shows, actually, I think this report was dated back in 2018. Now, as you can see here, the capex, the capital which is being poured to grow 5G, right, is not straight away going to the handsets, which is denoted by this yellow bar, right? In fact, a lot of money is being poured on the blue bar, which is the infrastructure, which means a lot of money is being poured into the market to fiberize all the network. All right. Yeah, this one is a very good scenario. On the left hand side is where a typical 4G or 3G network looks like. Okay, you see, from the internet, from the core network, meaning the back end, to connect to the users, whether it's home or or mobile, right? You see that actually a lot of things are being used, like copper. Copper is basically your network cable, your coaxial, which is a more advanced cable, but it's still a cable. But a little bit of fiber and a lot of wireless. This is called the microwave link. All right, towers talk to each other mostly using microwave link. Okay, but microwave link is very laggy, so you won't be able to deliver 1 millisecond latency using this configuration. For 5G, you need to have fiberized everything. As you can see here, I highlighted in red. You can see a lot of the communications, a lot of the channel, the link is being fiberized. Okay, now this is why it is able, 5G is able to deliver such a low latency requirement, because everything is being fiberized. Okay, and in fact, 5G has a lot of standards that focuses a lot on the fiberization of the communication. In fact, between base station and so on and so forth, you can read about it. All right, this is basically just to show you the importance of fiber. Okay, and we have one company in Malaysia, that is one of my very favorite company. By the way, disclaimer, this is not a buy call. It's called time.com. is being helmed by a very visionary and very efficient management. Why I want to highlight this company is because Time.com, yes, to a lot of us, we see Time.com as, you know, the fiber operator. Yes, if I stay on a condo or in the office building, I will be able to subscribe to Time.com. But Time.com has so much other services, and one of them is they also provide the fiber infrastructure to mobile operators. In fact, they provide the fiber infrastructure for all the mobile operators in Malaysia. So you can imagine when 5G takes off, you know, really meaningfully takes off in Malaysia, whereby the mobile operators like Maxis, Celcom, Axiata, you know, I don't know, Green, all the new ISPs is coming online, right? They will all require fiber. Where they will all require fiber on these links here, okay? And they can actually build their own, which is very costly, or they can subscribe to, you know, Time.com's fiber, massive fiber network coverage. Okay, so this is one of the companies that is I focus on for the 5G theme. They are actually very innovative. In fact, they have been starting to get ready for the you know, the rollout of 5G services since 2018 to 2019. They have worked with Huawei, you know, to deliver this 10 gigabits passive optical network, so on and so forth. Basically, it means that, you know, they are ready. They want to get ready for the takeoff of 5G. Okay. Now, Time.com is an investment grade stock, as I mentioned. I think as of last week, the market cap is about 8 billion ringgit Malaysia. Is a quite a huge cap stock. I don't know about the price today. I didn't check. The PE ratio is about 25 times and decent dividend yield of 2%. All right, and what I like about it is because it is a very strong cash generating cow. So the operating cash flow yield is about 8%. Now, if you don't remember all this, right, I think I suggest you to look back in, I think one of our webinars two years ago or last year where we talk about these parameters. Okay, this is a very profitable business. The net profit margin is close to 30%. Okay, the top line for the past 3 years is growing at 9% per annum, and impressively, their net profit is growing at 21% per annum, which means that actually they are being more and more efficient. You know, they scale up. Once they achieve a certain economy of scale, right, whatever that comes in, right, are just pure profit. And what I like about this company is they are very generous in giving the dividends. They are on statistically speaking, on average, for the past 3 years, they have been giving out 50% of the net profit as dividends. All right, amazing company. Okay, so next we want to talk about, you know, from infrastructure. Now we move on to the consumer devices. All right, basically this is a more interesting topic for tonight, right? I think this webinar is a very timely because if we talk about if we were to talk about this topic last year or earlier this year, right, there is not much activities in terms of the consumer devices because the technology is not there. That's one. The supply chain is not ready yet. But today we can safely say, thanks actually to Trump's policies, right, it actually accelerate a lot of technological development as well as supply chain alignment, you know, to make this happen, right? And this is just the beginning. You will read about more and more news about, you know, 5G devices, consumer devices, whether it's your smartphone or your wearables like your watch, your Google, your smart glasses, you know, earphones, home speakers, so on and so forth, right? All these are what we call consumer devices. They will slowly be more and more intelligent, and the takeoff rate will accelerate in the near term. This is a report. This is a report by Qualcomm. I think just a couple of weeks ago, last week. Qualcomm just released their results, and then they say that, you know, they see that the 5G will really take off, you know, especially at the end of the year or next year with the introduction of iPhone 12. Okay, I'm not sure how many of you have already booked. It seems that a lot of people are still queuing up to buy the iPhone 12 despite the COVID. Yeah. Okay, so in the 5G global chain, again, this is a global scale. There are a lot of names. So we talk about the front haul, which means, you know, from the base station to the user, right? This is what we call the front haul. It's where we have the devices, UE is called user equipment. These are your consumer devices, whether it's handsets, whether it's your Wi-Fi routers, whether it is your vehicle that is connected to the internet. All right. Then these are the base stations. All right. As well, and then it connect to the backhaul, which is what we call the core network. This is where all the massive computers, this is where all the supercomputers are housed at. Okay, now along this supply chain, we can basically break into four classes: the material supplier, the semiconductor player, which we talked about in the last webinar, the devices assembly and system equipment, right? Okay, so for the context of Malaysia, we focus more on the semiconductor supply chain as well as the devices supply chain and the assembly services. Okay, a lot of our companies, technology companies in Malaysia, actually supply or they support all these what we call OBM, original brand owners, or IDMs, independent device manufacturers. Now, don't worry, if you don't remember this, please by all means refer to the previous webinar. I think that was back in October. I spent quite a lot of time, some time, to explain what are IDMs and what are OBM or integrators. Okay, but the key here is to find out how many of our local companies, technology companies, that supply to these things. Now, of course, if you have overseas portfolio, especially in the US, right, you can take a look at these. Most of these companies are listed anyway in the NASDAQ. We've got Broadcom, we've got Qorvo, Skyworks, Murata, Ericsson, so on and so forth. They're all listed companies in the US. Now, the only question is, do we have enough money to buy? Yeah, okay. So I'm not going to talk in detail. Basically, it's just to introduce to you, what are the landscape of the supply chain on the higher value chain. For us, we mainly are on the lower supply chain, where we supply services as well as manufacturing services to these companies here. Okay. Now, remember I talked about 5G requires more and more cells, more and more towers, whether it's big or small, right? So by extension, it also means that there will be the demand for the networking chips will be higher and higher. So there are many types of networking chips. It can be from your routers or your switching equipment like this. It can be your transport, these are the fiber optics, for your base stations, and all the way to your antennas. Okay, now this is the supply chain, the major supply players of this tower segment, which is mostly listed in the US, I believe. Yes. Okay. So I'll come back to this again, why this is important to us. In fact, a lot of Malaysian companies are supplying to a lot of these names here. All right. So I'm going to help you connect the dots to where the money is later. Be patient. Okay. Now, the next thing, other than this, is when we talk about fiber optics, right? The most important, the basic module of a fiber optic is what we call the optical module. All right, optics means your glasses, where you can focus light or you can transmit light. Based on this data, actually, the biggest players of optical modules will be 2-4. They command about 20% of the global market share, followed by Lumentum, followed by this FIT. This is Foxconn interconnector technology. Okay, now I think a lot of these companies have some of the manufacturing base in Penang as well, and that is why our supply chain are able to support them. In fact, I do know personally quite a number of companies that supply to Lumentum. Okay, now why I highlight these three is because I want to focus on FIT. FIT was actually is an optical company that was sold off by Broadcom before they acquired Avago, and then they buy back the company a couple years ago. So now it's not called FIT, it's called Broadcom. They are all under the umbrella of Broadcom. So what do? They manufacture all these fast switching Ethernet fiber optics. They manufacture the optical components on the small things that is used to connect to the fiber for broadband networking, and so on and so forth. Okay. So if you cannot visualize, no worries. I gave you this picture. If you guys are familiar with your desktop, not your laptop, desktop, if you look behind, you see this kind of, we call these the cards, different cards or fabrics. Okay, so I'm sure that you guys have seen this cable before, right? Now this is what we call the copper cable. Do you remember I showed in the previous slide? This is the RJ45 copper cable. Now, there's a difference between this cable, this blue cable, and this green cable here, this green and yellow cable. These are the fiber optics cable. It's very different, but visually, if you don't understand, if you have not seen this before, you think that they are the same, but they are very different. Okay, here the medium is copper or wires. Here is about fibers. All right. Now, if I take this card out, you see it looks like this. So of course, inside the card there is this PCB, you know, the electronics. But the most important thing here is this part here called the fiber optic transceiver. Now, what is the meaning of transceiver? It means transmit and receive. So this card needs to be able to transmit in signal and receive signal. What kind of signal? It will receive signal, optical signal. It receives light, and then this device need to convert the light into electrical signal, so that it can be processed by the computer. Now, once after the computer process the data and needs to send the feedback back to the internet, it needs to convert the electrical signal to light again to transmit into the fiber optics. All right, and that is why this is very important, the fiber optic transceiver. This whole module is called transceiver, but the semiconductor or the device inside this transceiver is called the optocoupler. Okay, now why do I spend so much time talking about this? There is a reason. Because we have one such company in Malaysia listed in KLSE that does this, and they are none other than INARI AMERTRON. Now, INARI AMERTRON is I think the largest cap technology company in Malaysia. All right, they are very professionally managed. One of their key customers is actually Broadcom. Remember Broadcom? So Broadcom is the third largest optical module producer in the whole world, right? So we've got a company, homegrown company, you know, that supply to Broadcom, because one of the key segments of product is what we call the fiber optic transceivers. Okay, INARI engaged with Broadcom to secure mixed signal test business across product lines, blah blah blah, including networking and Wi-Fi. All right. Then 5G will increase the demand of IoT as well as factory automation, and this will further push the demand for optocouplers. Remember, I talked about optocouplers, which is the semiconductor inside here. Okay, that support automotive and industrial automation. Now, INARI's optocoupler products are being produced in Philippines in their Clark key base. So they have a couple. They have got a lot of manufacturing plants spread across the world, mainly in Malaysia, but they got some as well in Philippines. So what they do is in Philippines they produce the optocoupler like this. As what I mentioned here, right? Then they'll ship the optocoupler back to the Penang plants to package it, you know, into something like this. To package it into something like this, so that they can ship it back to their customer, Broadcom in US, so that they can produce the whatever that is being used for the networking equipment. Yeah. So this is one of the companies that is a major supplier to Broadcom. Yeah. Okay. Now the other thing about this, so this is about still about the infrastructure, because this is about switching equipment. Remember, if I focus back here, so this part is still about this, is still from this portion here, all right, whereby we have the base station and the computers on the core network. Now we want to focus on the front end, the user, the end user, or what we call the consumer device. All right, so one of the most common consumer device is our smartphone, right? Now to us, it just look like a, you know, a piece of black color candy bar. This is called candy bar form factor, but inside there are a lot of electronic components, and one of the most important electronic component is called the RF filter. Now again, in a very layman term, RF, radio frequency filtering, means, you know, in the air there's a lot of noise, a lot of different type of signals, right? So how does your phone or your device know which signal to tune to, which signal to listen to, which signal to process? So we need this thing called the RF filter. You filter out the noise, you only take in, you only allow the meaningful signal to come in. Okay. Now, as you can imagine, from 2G, which is voice, you don't need to do a lot of data processing, to 3G, to 4G, where you need to have some data processing, right? So it is easy to imagine that the more advanced your smartphone is, you need to have more advanced filtering, isn't it? Okay, so much so that based on this company, this Resonant is a listed company in US. Okay, as you can see here in the 2G phones, back in the 2007, right? One phone, the RF filter costs less than $1. But if you fast forward to today, the first feature 5G phone here, it can cost up, the RF filter can cost up to $38 per phone. Now, I think the recently launched iPhone 12 for the 5G one, I think the lowest range is about 1,002, 1,003 US dollars. So if you divide the $38, $40, 2002, right, you get about 3%. Meaning, can you imagine? And this is retail price. So if you look at production price, it's even higher. And the contribution of RF filter is even higher. So imagine you spend $1,002 to buy a 5G phone, iPhone 12. 3% of that cost is to pay for the RF filter. You can imagine how important or how lucrative this RF filter is. Okay, of course, in a smartphone or consumer device like this, is RF filter the only component inside? Nope, not obviously not. There are many types of RF modules. We call the RF front-end modules, right? From the switching equipment to the amplifier to amplify your signal. After you filter, you need to amplify the signal, right? Okay, and then the chipset, which is the processors of this RF, right? So in this space, so this is something that we compiled a couple of years ago from wallstreet.com.cn, one of the research papers that we study. The most in the RF components, right? RF filter carries the highest value. It's much more expensive than the switch. It's much more expensive than the power amplifier and the chipset. All right. Now the RF filter, there are two types. One is called the SAW, or what we call the surface acoustic wave, or the bulk acoustic wave. Now, why are these two different? To be able to be used for higher frequency, like in 5G, you need to have BAW, or the bulk acoustic wave. The SAW is good for the older technology like Wi-Fi, 3G, 4G, maybe even 4G start to use this BAW. And you can see here, there is a major winner here, or the major supplier in the FAW space. Who is it? It is Broadcom. Broadcom, based on this data, commands about 87% of the market share for BAW. I think the number should be different from now, but it should be more or less perhaps maybe 80-20 type of distribution. So Broadcom has their own proprietary BAW filter called the bulk acoustic resonator called FBAR. All right, and if you ask, you guess it right. Do we have a company that supplied? Definitely. All right, INARI also supply the RF system in package modules for Broadcom as well, for the RF filters, right? So as you can see here, the more advanced the filter is, it requires more testing, more packaging, and that is where INARI comes in. Okay, so INARI again is one of the biggest market cap companies in technology companies in Malaysia. As of last week, it's about 8.8 billion. I think it should be more or less the same today. I think the price today is about 270, but the PE ratio is slightly premium, about 56, 58 times. The dividend is slightly lower, about 1.6%. They are in a very strong net cash position, meaning if you compare the cash with their total debts, they are net cash. Now, other than Broadcom, they also serve other clients like Osram, Lite-On, PCL Technologies, so on and so forth. These are major fiber optics and RF players. Okay, so this is about INARI. Is INARI the only company in Malaysia that supply to these 5G consumer devices brands? Definitely not. So I'm going to skip this for now. So the other thing is called the power. Power. RF power is also a very important element in 5G. So just now we talk about consumer device, but these are, when it comes to base stations, right? The requirement for 5G, for the power requirement for 5G base stations is much higher than compared to 4G and 3G. Why? Remember I talked about the different antennas where we have MIMO, where we can beam the signal very to a particular angle to a particular user, right? So it requires very advanced or very high powered base stations, and a typical power semiconductor like LDMOS will not be able to produce this kind of effect. For 5G usage in especially the base stations, right, we need to have more advanced material like GaN. GaN stands for gallium nitride. Okay, as you can see here, these are the physical characteristics of the different materials. It's very clear that GaN, they have much higher power density, meaning for the same power, they are able to deliver more to using the same power. Okay, so they are being applied for 5G base stations or even a small cells. Okay, but the problem is they are very expensive compared to the other materials. Okay, and we have one company in Malaysia. Oh, sorry, before that, the key player for GaN today is this company called Cree. CREE is a US-based company. They used to do LEDs, but a couple years ago they invested $1 billion US, more than that, to acquire this company called Wolfspeed. All right, Wolfspeed is a major player in GaN and SiC. SiC is silicon carbide. All right, and these are the advanced material which is going to be very, very important for 5G applications. Now, not only for 5G, for your electric vehicles, so on and so forth, there's the wide range of usage. But today we're going to talk about from the 5G angle. Okay, so Cree, after they acquired Wolfspeed, right, they ventured into the 5G space directly. So who is the supplier that produces for this company? Is Globtronics. Okay, now Globtronics has been a supplier for Cree for more than 15 years, but of course when they started out, right, they do not, they only supply the LEDs. Remember, Gtronic was one of the major LEDs producers in Malaysia, but Gtronic has a couple years ago started venturing into sensors as well. Okay, so Cree is, by virtue of Wolfspeed, Cree acquiring Wolfspeed, right? So Gtronic is in a very good position to actually tap into this growing market. In fact, I think based on a few reports last year, right, actually we got a lot of hint already that Gtronic has started, hiring a lot of engineers to look at gallium nitride production semiconductor devices. You can look at JobStreet, you can see a lot of their, we do a lot of research in many angles. We don't just look at this analyst report. In fact, I myself like to go to jobstreet.com and find out what these guys are hiring, so that I can have a sense of what kind of technology that they're looking at. So Cree is one of their long-standing customers, and they stand to benefit, from this growing RF power market. And another big client of Gtronic is actually the AMS. Now, AMS is the biggest sensor producer in the world. All right, they produce sensors not only for consumer devices, they produce sensors, many advanced sensors for automotive, for autonomous driving, for biosensing, industrial IoT, so on and so forth. A plethora of markets and different applications. They have a lot of bases. They acquired Heptagon, I think 2 years ago, so they shifted a lot of production in Singapore as well. Why do I say this? Is because when they shift the production here, it will benefit a lot of the supply chain, the players around the region, including Malaysia. So Gtronic is AMS is the biggest sensor client for Gtronic at the moment. So, with the implosion of 5G and Internet of Things, right, Gtronic is poised to benefit from this relationship with companies like AMS as well as Cree, Wolfspeed. Okay, again, Gtronic is a much smaller market cap compared to INARI. They are trading about 2 billion ringgit market cap, I think, recently. The price is about 3 ringgit today, I think. PE is slightly cheaper, as lower than INARI at 45 times, still high, but they've got a pretty decent dividend yield of 2.5%. Okay, they are very profitable, more than 20% for the past 3 years. Now, what I like about this is, look at this. Granted that Gtronic for the past 3 years, there have been actually their top line, their revenue has been going down, reducing at about 10% per annum. In fact, it hits their net profit as well, about 4.4% per annum because of the trade war. Okay, but if you look at the operating cash flow, despite their revenue coming down, their cash flow has been improving year on year at about 50% year on year. Mind you, this is 50% on top of 50% on top of 50% for the past 3 years. And this shows you how strong is the operation. Okay. And what another thing I like about this company is the dividend payout. For the past 3 years, they pay out more than 85% of their profit, as dividends. I think they pay about 4 times a year, including 1 or 2 specials. I can't remember already. Okay. Disclaimer again, I'm a shareholder for Getronics, so when I talk about it, I'm very passionate. Okay. Yeah. So that's about. We talk about Timecom, we talk about INARI, and then we talk about Getronics. Okay. Now, due to lack of time, and for this webinar, we focus on 5G. I'm just going to introduce 2 more companies. One of them is PandaMaster. All right. Now, PandaMaster is also poised to benefit from the implosion of 5G telecommunications. Okay. So like Getronics, they also produce a lot of, they produce the ATE, the testing machines for MS as well. Look at this, MS. They also produce for, TVK and so on and so forth, right? So for PandaMaster, their major contribution of revenue is still coming from telecommunications, about more than 40%. But according to the management, they have been trying to diversify because telecommunications, yes, although it can generate a lot of revenue, but the profit margin is not as great as the other segments, like, for example, automotive or medical. So for now, for this webinar, I'm just going to touch base on this PandaMaster. Now, when I come back, I think next week, right, we'll be talking about automotive semiconductor next week. I'll focus more on PandaMaster. So be sure you register for the next webinar, yeah? Okay. Now, last but not least, I'm going to talk about this company. This is another wonderful company, okay, called Vitrox, again, based in Penang. That's why I like to go to Penang. So Vitrox has a lot of automated testing machines as well. They are one of the major ATE player in Malaysia. And one of the product line is what they call the AXI. AXI stands for Advanced X-ray Inspection System. So, any inspection system for semiconductor usually is using microscope, where you zoom in to very huge detail of the electronic component to see whether there are cracks or whether they are, soldered or they are aligned to the proper direction, so on and so forth, right? But sometimes you can't just use these optical devices. Why? Because I don't know. Let me try to use this book right now. Advanced electronic PCBs, like these the electronic boards that I showed you just now, right? To the naked eye, it looks like one piece, but in fact, there are many layers in between that one particular board. Okay, so maybe just let me explain using this table. Okay, as you can see here, for communications especially, right, for smartphones, normally one PCB board, the printed circuit board, maybe has a double layer. Yes, some may have 4 or 6 layers, but for the telecom equipment, including your base station, your networking switch, right, so on and so forth, right, it can go as high as 18 layers and above, which means what? One layer of PCB has 18 intermediate layers in between. Now, to the naked eye, you won't be able to see, right? Because there are a lot of circuits as well as components in between these layers. So what do you need? You need to have an X-ray system to be able to scan through the different layers to find out where are the faults. And that is what this AXI system does. You can see here, they've got these snapshots of what they can produce, like single pad, multi-pad, 3D CT image, just like when you go for CT scan in the hospital, whereby, the patient will go through a machine and then there'll be the machine will scan through the patient's head to produce 16 slices of images. It's the same thing. The concept is the same right here. So the XI machine will be able to produce the X-ray, right? And then based on what is reflected, they'll be able to see what's inside this PCB board, and that is how they detect the errors or the faults, and then you know, as we know that 5G, the components are very advanced, so you need to make sure that, you know, these small components are being assembled properly. Okay, so this is one of the things that VTROX does. So they're not just focusing on telecommunications. In fact, there are also quite a major player in automotive as well. Okay, so I think basically I've introduced 5 companies to you guys tonight. Started with Timecom being the fiber optics infrastructure player in Malaysia, the biggest. Talk about INARI, being the optical module producer for Broadcom, as well as the RF filter supplier for Broadcom as well. Then we talk about Getronic. Getronic supply to companies like Cree, Wolfspeed, as well as AMSAG, which are major players in the 5G space. We talk about Pentamaster, just touch base a little bit, as well as VTROX. Now, these are not the only companies in Malaysia that are related to the 5G supply chain. Yeah, so please don't get me wrong. Basically, I just introduced some of the major names in this space. But of course, if I have opportunities in the future when we come back, you know, maybe next year to talk about this topic again, hopefully I will have more case studies for you guys. Okay, so as my last concluding slide, I would like to maybe, you know, just rehash again one of the slide that I shared in the previous webinar. You know, in the future, right, what is the future trend in modern technology? Again, it's basically like a curtain whereby there are 2 pieces, is where it's really US and the Western world against China, particularly Huawei. Yeah, and you know, yes, you may say that, yeah, now Biden won the presidency and he's gonna be the next POTUS 46, right, president of United States 46, right? Does it mean that, you know, they are going to be more relaxed on China? Nope, I personally don't think so. In fact, they are going to continue to try to arrest the development or the progress of the Chinese technology as much as they can, as long as they can. And of course, hopefully, President Biden will be the more rational president compared to the outgoing POTUS 45. But one thing is for sure, that, you know, the war or the battle between US and China is not going to be tariffs anymore. It's going to run into the technology space. Okay, so this will lead to a lot of challenges as well as a lot of opportunities for us, especially in the ATE players and the OSAT players. So I'm not too worried about this. In fact, I'm very positive. In fact, I'm very, very excited about these changes, this paradigm shift in geopolitics, you know, because Malaysia is in a very sweet spot. We can have the best of both worlds. Now it is up to us to choose which girlfriend we want to date, you know, whether we want to date the Angmo, the Westerners, or we want to date the Chinese. Okay, but regardless, I'm sure with more than 100 listed companies in KIAC in the technology space, there are more than a handful of opportunities that we can look at for technology, as in particular 5G. Okay, so I hope that I have given you a good overview of the 5G, what 5G technology is about. I spent quite a lot of time to talk about, you know, what are the basic features of 5G, the technology that enables all this high speed and low latency, and how we can connect it to the supply chain, and who are the local players that is involved in these major these suppliers to 5G. Okay, so with that, thank you very much for your patience. I hope to see you again. All right, and this is a very wide topic. It won't take just one webinar to cover it. All right. Okay, back to you, Chun Xian. Are you around?
Yes, thank you so much, David, for sharing with us what exactly is 5G, what is its advantage compared to a 4G, 3G, 2G, and its application in the various sectors, and show us what are the companies that can benefit from these 5G evolutions. Okay, now that my mind has expanded and have headache now because once the mic expanded, I never string. Okay, so thank you so much, David, for sharing with us your research and also what companies can benefit from this. I'm sure if you have benefited from this session, please let us know in the comments so that we know that we can invite David back for more sessions. All right, so if any question to ask David, you may put it in the Q&A box, so we'll do our best to address them.